Welcome to In 5 Minutes. The agenda of this clip is to improvise the array multiplier which we made in the previous clip. We are going to make a minor modification, and with that modification we will see how we can optimize the speed of our multiplier further, or how can we obtain a more faster multiplier. So on your screen you can see something. This is nothing but an array multiplier which we discussed in the previous clip. We wanted to multiply 4 across 4 numbers, and for that we easily saw the multiplicand and the multiplier which is mentioned in the table below. For each one of them we drew the corresponding rough diagram, and then we made this final fair diagram, and we saw that for a 4 cross 4 multiplier we had used 4 half adders and 8 full adders. That is, technically if we have an n cross n multiplier we can deduce the same analogy. For a 4 cross 4 we had 4 half adders, 8 full adders, and how many AND gates we had? Yes, 16. If you see here, 1 plus 2 3, 3 6, 4 10, 13, 14 15, 16, and we had 16 AND gates. So this was our area, and at the same time we found our delay to be 23 nanoseconds. At that point of time we discussed that what would happen if I swap in my P4 stage, if I swap my full adder with a half adder. And the very idea why we are trying to do this is because currently, if you look at it smartly, the last stage is a stage of full adders where the carry is getting rippled. So even if I can replace one full adder in that block with a half adder, I will be able to achieve some speed which will be better than the current design. So let's see how is this going to happen. Let's quickly do that. So this is my diagram till P3. We have already done this, so I'm not going to repeat. I'm just going to straight away take the P4 block. P4 block, we have 3 AND gates. Let's quickly draw that now. We know this very quick. Now see that I'm not going to use a half adder here. I'm straight away going down and using a full adder. Remember, we have called this inputs as I, J and K. To this full adder I'm going to give I and J as my input, not K, I and J. And my third input is nothing but C3A, which is coming as a half adder from the previous stage. It will have 2 outputs. Because we are in 4th stage, we'll call it C4A and S4A. Again, I'm going to put one more full adder here, which will have S4 as one of its inputs, K as the second input, and C3B coming from the previous stage as my third input. I'll have 2 outputs again. One is going to be C4B, another one is going to be S4B, which is nothing but my P4. Is it? No, it's not, because S4B is still left, and so is C3C. Remember, this is also left, so we'll need 2 inputs now. So we'll need another half adder which will have S4B and C3C as its input, and output would be C4C and S4C, which is nothing but a P4. See, we added one more additional row, but in the critical path in the previous row we will see what change we made. Let's quickly go ahead and make this in the fair. So we saw that there will be no half adder present. We'll straight away go ahead and use a full adder. So this is my full adder in that stage. This AND gates we have already understood in the previous clip, so I'm not going to explain that again here. Because it's a full adder, it will have 3 inputs. So one of them is I, other one of them is J, and third one of them is nothing but C3A. It will produce 2 outputs. One is going to be C4A, and another one is going to be S4A. The next block is also a full adder. So this is my full adder again. One input as S4A. The other input is nothing but my K input, which is coming from here. And my third is nothing but my C3B, which I'm taking from here. So see that this full adder in the previous case was taking the output at the same level. Now it is taking the output of one level above. So there is no rippling, because all these adders in this row are going to work parallelly or simultaneously. So here we have 2 outputs. This is C4B and this is S4B as well. I'll use an orange color for my sum, S4B. Now S4B needs to be added with C3C, so we'll need a half adder circuit. So half adder is coming and an additional row is what we are going ahead with. So this is S4B with other input being C3C. It will produce two outputs, C4C and S4C, and S4C is nothing but my P4. So what I have done is, in the previous diagram, if you see, here there was a half adder, full adder and full adder, whereas this full adder was taking into the ripple effect. This is the diagram here, half adder, full adder and full adder. What I did was I removed this half adder, kept this full adder as it is, kept this full adder as it is, but did not take the input from this and pass this to the next stage below, which is shown here. So the rippling is avoided to an extent.